Alright, so how do you find the derivative of this? We know y prime is going to be equal to what? Well, we know the derivative of natural log is going to be 1 over x, right? So it would be 1 over ln 2x to the power of 4, right? But we also have to use chain rule because this is an inside function. So it'll be 1 over 2x to the power of 4, because 2x is also the inside function of this natural log, right? And then now we need to multiply by the derivative of the inside function. So that would be 8 times x to the power of 3. That's your answer. Alright, how do you find the derivative of this problem? Well, we know that the derivative of e to the x is just e to the x. So we can just say that y prime is equal to e to the 3x, right? But this is an inside function, correct? So now we use the chain rule. Derivative of that is just e to the 3x. And now, since 3x is also an inside function, we have to multiply by the derivative of 3x, which is just 3. So that is our answer. Alright, so how do we solve this problem? Well, we know that the square root of natural log x is equal to natural log x to the power of 1/2, correct? So we can just simply use power rule and chain rule to do this. So y prime is equal to 1 over 2 root ln x, correct? But since natural log is an inside function, we multiply by the derivative of natural log, which is 1 over x. So now we know that this derivative of this would just be natural log x times x there. That's our answer. And if this part is confusing, let's think about it like this. What is the derivative of root x? Well, we know that square root x is going to be x to the power of 1/2, right? So by power rule, this will turn into 1/2 times x to the negative 1/2. And that means that it would be 1 over 2 x to the power of 1/2, because the negative sign makes x on the denominator. And now that is equal to 1 over 2 square root x, which is what this is. So how do we find the derivative of this problem? Well, I always like to write out the square roots as power. So log base 5, this is x squared minus 1, and then power of 1/2. Alright, so we can tell that this x squared minus 1 to the power of 1/2 is an inside function, and the log base 5 is the outside function. And what we know already is that the derivative of log base a x is equal to 1/2 times 1 over natural log a, right? So let's just do that. So y prime is equal to 1 over, remember it's 1 over x, and whatever's on the inside, so that would be x squared minus 1 times the natural log, 1 over the natural log of 5, whatever the base is. Now we have to use chain rule, because this is an inside function. So we would multiply that by whatever the derivative of this inside function is, and that happens to be 1 over 2 square roots x squared minus 1. But there's an inside function here, which is x squared minus 1. So we need to multiply the derivative of that inside function. So that would be 2x. Now we can definitely simplify. So since there's a square root here and a square root here, and the inside part is the same, the square root goes away because they're multiplying, right? So whatever goes on the top would be 2x. So 2x over 2 times x squared minus 1, no square root there, times ln 5. And the 2 goes away because it's on the numerator and on the denominator. So x over x squared minus 1 log 5. That is your answer. Alright, so let's get into some integrals. So since there's this plus sign here, it's kind of annoying to integrate it, but we can get rid of it using u substitution. So u is equal to 1 plus 5x squared. Then we differentiate both sides. Du over dx is equal to 10x. And then we find out that du is equal to 10x dx. So we need to change this dx to a du, correct? So now we're going to multiply by 1 over 10 on the outside. 1 to 0, x over 1 plus 5x squared times 10 dx. And we put this 1 over 10 on the outside because we're multiplying by 10 on the inside, right? So now this will equal to 1 over 10 from 1 to 0, 1 over u du. Now we know the antiderivative of 1 over u will be equal, or 1 over x. We know that the antiderivative of 1 over x will be equal to the natural log of the absolute value of x plus c, right? So let's use that. And the reason why it's the absolute value of that, because 1 over x has a domain of just x cannot equal 0, correct? While with this one, it's x has to be greater than 0, right? So in order to make the domains the same, you have to use the absolute value sign. Alright, so using that, we know that 1 over 10 times natural log of u 1 to 0, so it's just sort of simple here. So 5x squared, plug in whatever u was, which was 1 plus 5x squared, and then u from 1 to 0, evaluate from 1 to 0, so we go 1 over 10 times natural log the absolute value of 1 plus 5 squared, correct, minus 1 over 10 times the natural log of 1 plus 5 times 0 squared. Looking at this will equal to 0 because the log of 1 will be 0. So this whole term goes away, and it just turns into 1 over 10 times natural log of the absolute value of 6. That is your answer. So when I have problems like this, I like to ask myself, is there an inside function here? And if I take the derivative of that inside function, is that also there? So if I set u to x plus e to the x, right, and I take the derivative of that, that is going to be equal to 1 plus e to the x, correct? And oh wow, that's right there. Isn't that crazy? So now that means we can make du in there. So this would be equal to 1 over square root u du, because du is just equal to 1 plus e to the x times dx. And that is right here, correct? With this, I would like to just turn it into u to the power of negative 1/2 du. Now we can just simply do it normally. So integrate normally. So it'll be 1/2 over 1/2 u to the power of 1/2 over 1/2 plus c. And now we can substitute whatever u was before back in. So that would be x plus e to the x power of 1/2 over 1/2 plus c. So that just turns into 2 square root x plus e to the x plus c. That is our answer. Alright, so what about this problem? Well, the reason why we can't integrate it the way that it is because of this addition symbol. Correct. So we need to use substitution to make that go away. So 1 plus 3 to the power of 2x is equal to u, and if we integrate both sides, well, what's the derivative of 3 to the power of 2x? Well, let's see. So if we're taking the derivative of something to the power of x and the base is not e, then the derivative will equal to a to the x times ln a. Let's think about this. 3 to the power of 2x times, well, ln 3, but this is sort of an inside function, correct? So we need to multiply that by 2. So du is equal to 3 to x times ln 3 times 2 dx. We don't have these things in this ln 3 times 2 in here already. So we're gonna sort of make it. So we're gonna multiply it by ln 3 times 2, right? And the reason why we're dividing by it is because we're gonna multiply it by it in here. Let's put it down below. Multiply this by ln 3 times 2 dx. Alright, so that turns into 1 over ln 3 times 2 integral of 1 over u du. Simple. Doesn't that look so much better? So now we can do 1 over ln 3 times 2 natural log. Don't forget the absolute value sign. 1 plus 3 2x, because that's what u is, correct? Plus c, correct. So now that turns into ln 1 plus 3 2x over 2 times ln 3 plus c. And this is your answer. Alright, so here's one last one. I think it's kind of obvious what to make u, because we have function in here, correct? And we have its derivative. So u can be equal to natural log x. So we know du over dx will be equal to 1 over x. So then du is equal to 1 over x dx, correct? So now this turns into u squared du. Now we just integrate normally. Plus c, don't forget that. And then now we have ln x cubed over 3 plus c. This is your answer. Let me know if you have any questions.